All right, let's jump right in. Welcome everyone to today's Explainer. I want you to treat this session like a focused whiteboard lesson where we're going to map out a really massive shift in technology. Today, we are unpacking a fascinating and honestly highly urgent 2026 paper published by the Responsible AI Institute. It introduces a comprehensive system called the TrustX Arc framework, and it tackles what is arguably the biggest headache currently facing tech regulators and developers alike: governing agentic AI. So, to really grasp why this paper is an absolute game changer, we gotta ask ourselves a fundamental question. What happens when AI stops suggesting and starts acting? Think about it. I want you to imagine an AI that doesn't just, draft a polite email for you to review. Imagine an AI that autonomously sends that email, decides to delete the original message, and then completely wipes the local server without ever asking for your permission. We are rapidly moving from AI as an advisor to AI as an independent actor, and that changes the threat landscape entirely. And look, real-world incidents from 2025 brilliantly illustrate why researchers are so worried about this. They effectively view that year as the AI Wild West. We saw a state-sponsored group known as GTG 1002 manipulate a Claude code assistant to conduct autonomous espionage on global targets. Then there was the ID Oster vulnerability, which exposed over 30 remote code execution flaws across different AI tools. We even saw rules file backdoor attacks using completely invisible Unicode characters. The crucial takeaway here is that these multi-stage attacks were executed by AI systems without human involvement. Right, so that brings us to Section 1, the Agentic AI problem. Let's look at why our current safety nets just aren't cutting it. The governance gap we are facing exists because of a really stark contrast between what we built our laws for and what we are actually dealing with today. On one side of the equation, we have traditional AI, established frameworks like the EU AI Act or the NIST AI Risk Management Framework. They were designed for passive, human-prompted systems that give advisory outputs. You ask a question, it gives an answer. Simple. But on the other side, agentic AI features high autonomy, multi-step planning, and direct environment manipulation. You simply cannot use a rulebook written for a passive chatbot to police a proactive, autonomous digital worker. It's like trying to regulate a self-driving car using the rules of a bicycle. Moving on to Section 2. Meet the ARC framework. This is how the researchers propose bringing some much-needed law and order to the Wild West. But here's the thing. Before you can govern an agent, you have to actually prove it is one. To do this, the ARC framework uses a model called GPA plus IAT. Let's break that down. Minimal agency requires goal, perception, and action, the GPA part. Think of it like giving a 15-year-old a car that only drives straight. Sure, it does something, but it's limited. But a true agentic system, that adds iteration, adaptation, and termination, the IAT. That is like giving that exact same teenager the ability to autonomously adapt to heavy traffic, reroute around a sudden accident, and then park the car without you even being inside it. Okay, so how does this framework actually process the system in the real world? It follows a really rigorous 4-step pipeline. Step 1 is that agency classification we just talked about, figuring out what we're dealing with. Step 2 measures the autonomy level, scaling from level 1, where a human operates everything, all the way up to level 5, where the human is basically just a bystander observing. Step 3 is a comprehensive 12-dimension scoring rubric. And finally, Step 4 synthesizes all of this data to assign a final risk tier. It's an incredibly logical pipeline that takes an agent from a raw, unknown input right to a tightly governed output. Let's zoom in on Step 3 for a second, because this is really the beating heart of the ARC framework. The 12-dimension scoring rubric asks the hard, so what questions. We're measuring things like autonomy and temporal coupling, meaning does the AI take one isolated action, or does it run in continuous autonomous loops that compound the risk over time? We look at reversibility. If the AI makes a mistake, can we just hit undo, or is it permanent? And of course, blast radius. If this specific agent fails, does it just annoy a single user, or does it take down the entire enterprise network? But get this. Here is the absolute most fascinating part of their methodology, the critical dimension rule. If any single one of those 12 dimensions scores a 3, which means high risk, the entire AI system automatically jumps to the high-risk tier. Why? Because the researchers believe fatal flaws should never be averaged away. You can't have an AI with a low blast radius, but fully autonomous, irreversible actions, and just call it medium risk. One single strike of extreme risk, and boom, the system is flagged. Let's head over to Section 3, the Coding Assistance Exception. This is a massive, built-in exception to the ARC framework.
So why do AI coding tools get their own specialized evaluation track? Well, the reason is simple, but honestly, it's pretty terrifying. Coding assistants literally hold the keys to the software supply chain. Unlike a standard chatbot that just talks to you on a web page, coding assistants directly write, modify, and execute code right inside your secure environments. They totally bypassed standard external AI risks because, well, they're already inside the house. They have direct system access, which means any vulnerability they have attacks the very core of your digital infrastructure.
And because of that internal access, Arc basically swaps out its standard metrics for a highly custom 20-factor capability assessment. We aren't just worried about an AI giving bad advice anymore, we are hunting for supply chain poisoning. We're looking out for invisible Unicode character attacks that hide malicious commands in plain sight. We're tracking permission bypasses, what developers playfully call YOLO modes, along with command injections directly into the terminal, and complete autonomous workflow hijacking. These specific threats require a totally different lens of governance.
Okay, time for Section 4, Real-World Risk Scenarios. Let's actually put this scoring methodology to the test.
So, let's contrast two very distinct profiles. Consider a standard knowledge assistant, like an internal RAG chatbot. It's purely advisory, it's directed by a human user, and it only remembers things for that specific session. Arc scores this as Tier 2, medium risk. Simple enough. But an autonomous enterprise agent, that operates very differently. It runs in continuous feedback loops, it's completely unsupervised, and it has an enterprise-wide blast radius. Those specific traits trigger that critical dimension rule we talked about, pushing it immediately into Tier 3 high risk. That means it requires rigorous security controls and literally board-level approval.
And the final data reveals just how stark this difference really is when you run these agents through the rubric. A knowledge assistant scores a 14. A transaction agent scores a 15. But look at the autonomous agent. It absolutely rockets up to a score of 28. This proves that the ARC methodology isn't just some theoretical academic exercise. It actively categorizes and separates passive tools from highly potent autonomous threats. And that allows risk officers to allocate their expensive security resources exactly where they are needed most.
All right, let's wrap things up with Section 5, Future Impact and Takeaways. What does all of this mean for the future of AI innovation?
Now, the researchers are actually very open about the debate their framework creates. On one hand, the limitation is that strict rules, especially that really unforgiving critical dimension rule, they might temporarily slow down high-reward, innovative AI deployments. But you have to look at the other side, the long-term impact. Building proactive guardrails today ensures your product will actually survive tomorrow. Because when binding, strict government regulations eventually arrive, and they will, systems built with our compliance are going to thrive, while ungoverned, reckless systems will simply be banned.
I actually want to read this quote directly from the researchers, because it really hammers home the entire philosophy of this paper. Quote, "No amount of low-risk properties should offset a single high-risk property, because it does not provide adequate awareness towards the issues that truly matter." End quote. I mean, it is a bold, uncompromising stance on safety. They're asserting that in the world of autonomous agents, a single point of catastrophic failure is all it takes. Which leaves us with this final, pretty provocative thought. Will strict governance stifle AI innovation? Or is it literally the only way it survives? As AI agents transition from being these helpful little advisors to autonomous actors with their hands firmly on the steering wheel of our enterprises, the Wild West era is rapidly closing. Frameworks like Arc are forcing us to decide right now how much freedom we are willing to trade for safety. Thank you so much for joining me for this explainer, and keep questioning the technology you build and use.